call is now being recorded.
Okay, let's get started with this one. So this video will be covering everything to do with advanced algebra. So just like all the other sessions, we'll start off with all the easier ones and then we'll move over to the harder ones. So they'll get progressively harder each time. So question 1, we're starting off with some quadratic equations. So remember, quadratic equations can either be U-shaped or N-shaped. We'll go over that in the graphs class, but just keep that in mind. And they always have the form y equals ax squared plus bx plus c. So they'll usually have an x squared, an x, and a number. They don't necessarily have to have all of them, but they have to have the x squared. That's the most important identifier in it being a quadratic. That's a bit of background. So let's factorize this. So when we're factorizing, we're putting into brackets. So we're factorizing y squared plus 13y plus 30. So we need two numbers at times to give us 30 and add to give us 13. So we're going to set two brackets, put a y in each of these, and I need two numbers at times to give me 30 and add to give me 13. You could just list the factors of 30 and just try them. So 1 times 30 is 30. And 1 add 30, well, that definitely doesn't give us 13, so we'll have to just keep trying. We could try a number like 10 times 3, which gives us 30, and 10 add 3 also gives us 13. So it's all about trial and error, and you get better in time with this. So it's y plus 10 times y plus 3. Keep that bracket a bit closer. Okay, moving on. Factorize x squared minus 49. So this is a special case scenario. We've got a negative sign here, and we've got two squares. So we've got x squared, and 49 is also a square number. So we can list the square numbers. The square numbers are 1 squared, which is 1, 2 squared, which is 4, 3 squared, 9, 4 squared, 16, 25, 36, 49, and so on. These are all the square numbers. So as soon as you notice two squares and a minus sign, this is difference of two squares. And what you do here is, it's just a method you need to remember. So your answer is going to be two brackets. You square root the first term. So the square root of x squared is just x. We put a plus in one, a minus in the other. It doesn't matter which order you do it in. You could even put the plus here and the minus here. It doesn't really make a difference. And we square root the square number. So the square root of 49 is just 7. So our answer is x plus 7 times x minus 7. So that's our answer for that one. Let's keep these highlighted so you can see which one's the answer. Okay, moving on. Question 3, factorize x squared minus 7x plus 10. So again, we just need two numbers at times to give me 10 and add to give me minus 7. So a trick here is you should notice that minus 7 is negative, whereas the two numbers with times in plus 10 is positive. So we'll need two negative numbers to be able to make minus 7 and two negative numbers times to also give minus 10. So it won't be minus 1 minus 10 because minus 1 add minus 10 is not minus 7. Let's try minus 2 and minus 5. So minus 2 times minus 5 gives us 10. And minus 2 add minus 5, well, that's the same as minus 2 minus 5, which is just minus 7. So that works. So we can say x minus 2 and x plus x minus 5, sorry. So there we go. That's factorized. And then part B to that just says solve this. So in other words, we get our factorized equation. We make that equal to 0. And what this is basically saying, a number times a number gives me 0. And the only way you can get 0 is that one of these numbers have to be 0, because 0 times something gives you 0. So we could either have x minus 2 equaling 0, or we could have x minus 5 equals 0. So you might have been told just change the sign, but that's the reason why we do it. So therefore x equals 2 because we plus 2 to the other side, and here x equals 5. And that's our answer. So x equals 2 or x equals 5. Okay, so that's for part B. Moving on, we've got solve 2x squared plus 13x plus 7 equals 0. So we've got a number in front of here, which makes this a lot more trickier to just do our two bracket method. So in this case, I'm going to be using the quadratic formula, and you'll get given the quadratic formula in the exam. So x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And another clue that we're using the quadratic formula is it's saying give your solution to two decimal places, which shows that it won't be a whole number, so therefore we can't factorize it and put it in a neat bracket. So that's another clue as well that you're using the quadratic formula. So first step in using the quadratic formula, we're going to find what's a, what's b, and what is c. So a is just a number in front of x squared, which is 2. B is a number in front of x, which is 13, and C is just the lone number, which is 7. Be careful that this is in the right order. So something x squared, something x, and something a number. They might mix it up in the exam. Make sure you put it in the correct order before you state what is A, B, and C. And now we're just substituting all these into the equation. So we've got x equals minus b, which is minus 13, plus or minus the square root of b squared, which is 13 squared. And 13 squared is just 169. We've then got minus 4ac. So we can do minus 4 times a, which is 2, times c, which is 7. So we get minus 56, divided by 2 times a, which is 2 times 2, which is just 4. So I would recommend not just sticking every single thing into the calculator once, because you might end up getting an error. And usually when you do end up getting an error when working with these, it's because you've made this square root negative. You can't square root a negative number, it'll give you an error in the calculator. So I would recommend doing this in parts. So let's simplify this further. We get minus 13 plus or minus 169 minus 56 gives you 113. So we're square rooting 113. And 113, that's not a square number, so most likely we're going to get a decimal. It's a third. Divided by 4. It says give your solutions correct to two decimal places. So in my calculator, I'm either going to stick x equals minus 13 plus root 113 over 4. And I'm also going to stick in x equals minus 13 and then the minus version, root 113 over 4. So putting these two in the calculator, let's see what we get. So I'm just going to put the answers here. So putting them in the calculator, you get x equals, I'll put that there, I'll just write what x actually does equal. It's minus 0.59 to two decimal places, or it's minus 5.91. So biggest tip I would give you with quadratic formula, do it in parts. So don't just stick everything into the calculator because you'll end up getting errors. So just break it down slowly. Okay, so that's question 4. Moving on to question 5. We've got solve x squared plus 2x minus 7 equals 0, and it says give your answer in essentially third format. So we're using the quadratic formula in this case. Now, if you look at the quadratic formula here, we can see we've got this third here. So we're going to be using the quadratic formula, but then not going the whole way. We're just going to leave our answer at this stage, which is what it says here. So let's bring the equation down here. So again, that's a big clue that we're using the quadratic formula because it's got that third there. So what is A, B, and C? A is just 1 because the number in front of x squared is just a 1. B is 2 and C is minus 7. Sticking everything in, we get x equals minus b, which is minus 2, plus or minus the square root of b squared, which is 2 squared, which is 4. Then we've got minus 4 times a, which is 1, times c, minus 7, which gives us 28. So we're plussing 28, all over 2 times a, which is 2 times 1, which is just 2. I can simplify that further. I get minus 2, plus or minus the square root of 28 plus 4 is 32. And that's a third. And we're dividing that by 2. Now, we just need to get creative and think, what can we break that third down into? So let's just do it to the side over here. So root 32, just so we can see where we can simplify even more. We could break that down into, well, let's half it. What do we get? 16 times 2. So 16 times 2 gives you 32. And 16 is a square number, so we can split that off into 16, root 16, and root 2. The square root of 16 is just 4, so we get 4 root 2 for this one here, so we can rewrite that. So we can rewrite this to minus 2 plus or minus 4 root 2, all divided by 2. And in our final answer, we've not got any denominator, so that 2 is going to cancel out everything. So let's put our answer in red. Minus 2 divided by 2 is minus 1. We've then got plus or minus 4 root 2 divided by 2 is just 2 root 2. And that's my final answer for 4 marks. Okay, moving on to question 6. We've got factorise 2x squared plus 5x plus 2. Now, you can use, there's quite a few different methods you can use for this. So you can use AC method, you can use a bit of trial and error. But because it's 2 marks, you don't want to spend a lot of time thinking of factors. So I'm just going to show you the quadratic formula method to do this and work the quadratic formula method backwards. But you can use AC method. Nothing wrong with using the AC method. With the quadratic formula, it just means less thinking because you're just plugging all the numbers straight into the formula and it just works. So we've got A equals 2, B equals 5, and C equals 2. So this time we're not solving, so we're not finding what x is, we're factorizing it. So there's an extra step to do. So I'm going to substitute everything into the formula and show you what we get. So x equals minus b, which is minus 5, plus or minus b squared. 5 squared is 25. We've got minus 4 times a, which is 2, times c, which is 2. We get minus 16, all divided by 2a, which is 2 times 2, which is just 4. We've got minus 5 plus or minus 25 minus 16 gives you 9, and the square root of 9 is just 3. So I can put 3 there, all divided by 4. So I've got 2 answers of x. I've got minus 5 add 3 divided by 4. So minus 2 divided by 4, so minus a half. And we've got x equals minus 5 minus 3, which is minus 8. And then minus 8 divided by 4 is just minus 2. So we've solved it. Now, a lot of people say we don't like using the quadratic formula because it takes time. But the more you practice it, the easier it gets. So that was quite easy to do, just doing it in parts. Don't get too overwhelmed with it. Practice makes perfect. But we've not factorized it. We've solved it. So we need to factorize it for this question. So what you can do is our 2 brackets, if you think backwards, so this equals 0. If we were factorizing this and our 2 answers were minus a half and minus 2, we have to just change the sign. So really in my brackets, I've got x plus a half, and we've got x plus 2. So you change the sign to both of these when you stick them into the bracket. Reason why, imagine we factorized it in the first place and we solved it, then that gives you x equals minus 2, because that's what x equals when you factorize it. So we're going backwards. However, when we're doing factorizing, we're not allowed fractions here. We have to have integers, so whole numbers. So what I'm going to do is this here, I'm going to times the 2 up to here. So I'm just going to change that first bracket. I'm going to put this in red. So I get 2x. Let me just remove that because it doesn't equal 0. Plus 1. So times the 2 up. And then we can keep the second bracket as is, since 2 is an integer. And that's our final answer. So that's how you can factorize using the quadratic formula. So it's just less thinking, less trial and error, and you just get the answer immediately. So we can try it again for the next one. We'll use a quadratic formula method because I know a lot of people are not a fan of the AC method and thinking of 2 numbers when there's a number in front, especially if there's a 3 and you start dealing with big numbers. The quadratic formula just works nice and easily. Let's bring the quadratic formula down again. We're going to do it again for this one to show you how it works. So it says factorize this. Using the quadratic formula again, a equals 3, b equals 16, and c equals 21. We've got x equals, we're going to plug everything into the quadratic formula, and I'm going to go backwards. Minus b is minus 16, plus or minus b squared, so 16 squared is 256, minus 4 times a, which is 3, times c, which is 21, minus 252, all over 2a, which is just 2 times 3, which is 6. Simplifying that further, we get minus 16 plus or minus 256 minus 252 is 4, and the square root of 4 is just 2. So I can stick 2 there. That's all divided by 6. So nice and easy numbers to work with. So we get two answers of x. So we've got x equals minus 16 plus 2 divided by 6. So we get minus 7 over 3 for that. And x equals minus 16 minus 2, so minus 18 divided by 6, we get minus 3 for that one. Okay, let's get rid of that. Okay, so we've got our two x values, but we're not solving this. If the question said solve, we stop there. This question is saying factorize, so I need to get this into brackets. So just like last time, we are choosing the opposite sign, so x plus 7 over 3 and x plus 3. So we're just choosing the opposite signs to them and sticking them in brackets. However, we're not allowed this fraction here because we're only allowed integers. So therefore, I'm going to times this 3 up to there. So I get 3x plus 7 times x plus 3. And that's my answer. You can always check your answer in the exam as well. If you get time at the end, just times this out using your grid method or your FOIL method and see if you've got the right answer. So that's the answer for part 7. So you can use this quadratic formula method, or you can just stick with your AC method, or just trial and error, I guess. But it's all about timing the exam, and it's that exam technique as well. Moving on to question 8, it says factorize fully 2x squared minus 98. So you should notice that minus there probably signifies that it's going to be difference of two squares, but 2x squared and 98 are not square numbers. So what we could do is we could factorize that 2 out and see what happens. So if I factorize 2 out, I get 2 times x squared minus 2 times something gives me 98. Well, if I do 98 divided by 2, I get 49. And now this is a square number, and that's also a square. So we've got x squared and 49 is a square number. So we can do difference of two squares on the inside here and just ignore that 2 for now. So let's do difference of two squares on the inside. Leave that 2. The difference of squares for the inside part, we square root the first term. Square root of x squared is just x. Put a plus in 1, put a minus in 1. And what's the square root of 49? That's just 7. So 7, 7. And that's my final answer. So a lot of people got stumped with this one just because they didn't know to do that first step of factorizing the 2 out and then deal with it the difference of two squares method. So let's move over to quadratic inequalities. So the reason why this is a quadratic inequality, again, we can see something x squared, something x in a number, and we've got that inequality sign right here. Now, whenever you get a quadratic inequality question, you always must draw the graph. Always draw the graph. And as I do a few questions, you'll see why we draw the graph as well. And it tells the examiner as well that you've got understanding as to how to solve this. So when drawing the graph of a quadratic, we know it's going to be U-shaped or N-shaped. It'll be U-shaped if your x squared is positive. So it'll be U-shaped if your x squared coefficient is positive, and it'll be N-shaped if your coefficient to your x squared is negative. So keep that in mind. We know this one's going to be a U-shaped graph, so nice and simple, a U-shaped graph. And we need to know, where does this U-shaped graph cross the x-axis? So where does it cross here and here? And to do that, we just need to do what we've been doing in all the previous questions. We need to factorize it or use a quadratic formula and solve it. We need to find where does x cross the x-axis, so we're solving it. So let's attempt to factorize this one. We need two numbers at times to give me 3 and add to give me 4. That's nice and straightforward. So I can put x in both of them. And two numbers at times to give me 3 is 3 times 1. And then 3 add 1 gives you 4. So therefore, the two places that x crosses the x-axis, remember it's the opposite sign, So for x plus 3, it'll be x equals minus 3, and for x plus 1, it'll be x equals minus 1. So what we've essentially found is these are the two places that it's crossing on the x-axis. So let's draw a rough sketch now and see what happens. So let's draw it like this. Okay. So we've got minus 3 and minus 1 where it cuts. So it cuts at minus 3 and minus 1. So roughly there. What I would recommend first is, you know, it's going to be on that side. So let's just draw the curve first. The curve will look somewhat like this. Now, it's just a rough sketch, so it doesn't have to be really accurate. So it's crossing at minus 3, which is here, and it's crossing at minus 1, which is here. The next part, which you now need to look out for, is this graph. We want to solve it when it's more than 0. So when the graph is more than 0, it is above the x-axis. It's where that graph is above the x-axis. And I can see that this graph is above the x-axis here and here. So if the graph was, well, if it was less than 0, which we'll do another example, it would have been below the x-axis. So just to explain again, if it's more than 0, it's above the x-axis, and you're finding where is the graph that you've just drawn above the x-axis. Now we need two inequalities to represent these two sections here. So let's start off with this one here. So this part of the graph, remember, it's going to continue forever upwards. It's going to keep going. So it happens for all x values more than minus 1. So when x is more than minus 1, meaning so every value for more than minus 1, the graph will be up here. So for example, if x was 1000, the graph is still going to be up above the x-axis. So that's the reason why it's more than minus 1. And then for this part here, it's happening for all x values less than minus 3. Not more than minus 3, because if it was more than minus 3, it'd be down here. So you're going to write or x is less than minus 3. And that's your two answers. So you can see why we've drawn the graph. So we can actually spot what's going on in this case here. So you can see which part you're taking, essentially. So that's our two answers for that one. Let's do another example, but this time let's do it where it's less than 0 and see what happens in that case. That was for 3 marks. So this one says solve x squared minus 12x plus 35 is less than 0. So again, we're going to draw the graph. We know the graph is a U-shaped because it's a positive x squared coefficient. So we know it's U-shaped. We need to just find where is it going to cross the x-axis. So like last time, I'm going to attempt to factorize it. You can use a quadratic formula to solve for x as well. You'll still get the marks. You're just essentially finding where it crosses the x-axis. So two numbers at times to give me 35 and add to give me minus 12. That would be minus 7 and minus 5. So minus 7 times minus 5 gives me 35, and minus 7 add minus 5, which is minus 7 minus 5, gives me minus 12. So our two x values are x equals 7 and x equals 5, so just the opposite. And now we can sketch the graph. So sketching the graph. So it's just a sketch. When you say the word sketch, it just means it's not accurate, so you don't have to draw your coordinates bang on accurate. You're just doing a rough sketch. Now, this is crossing 5 and 7, so I know 5 and 7 will be around here. So let me draw my curve first to like cross them two areas. So it will look something like, let's just say that here. So where this is 5 and this is 7. So that's a rough sketch right there. Now, this time, we want to work out where is this graph less than 0. In the previous example, we worked out where is it more than 0, and that was above the x-axis. But this time, we're working out where is it less than 0. So less than 0 is below the x-axis this time. So where is this graph below the x-axis? And we can see that that occurs right here. So this point here is where the graph is less than 0. So we need an inequality that represents all the values between 5 and 7. So for every value between 5 and 7, the graph is less than 0. So all we say is x is between, so you say x is less than, so the pointing side is to x, and x is more than, because the big side is on x. You put a 5 here and you put 7 here. So that just represents all values is of x is between 7 and 5. Okay, so that's for 3 marks. Let's do another example. This time we've got x squared is less than or equal to, so it's got an equal sign underneath as well, which we're going to changes our answer. And we've got 100. Now remember, with quadratics, we always have to make it equal to 0. Same goes for this. I need to bring 100 over to the left-hand side. So I get x squared minus 100 is less than or equal to 0. Now you should recognize this as difference of two squares, because x squared is a squared term and 100 is a square number, and you've got a minus in between them, so that represents your difference. So we need to sketch the graph again, so let's factorize using difference of two squares. So we get x plus 10, which is the square root of 100, and x minus 10 is less than or equal to 0. So therefore, just taking the opposite signs, we've got x equals minus 10 and x equals 10. So that's the two places it's going to cross. Let's sketch the graph. So it's crossing minus 10 and it's crossing 10. So let's draw the graph first. We know minus 10 is roughly here and 10 is approximately here. So just drawing the graph, I will get something like this, where this is minus 10 and this is 10. Now we're working out, where is this graph less than or equal to 0? So just like the last example, that's below the x-axis again. So it's all these values here. So we need an inequality that represents all the values of x between 10 and minus 10. And that's just x is between 10 and minus 10. But because there's an equal sign under it this time, we're going to be putting an equals under both of them. And that's how you do this question. So a lot of people get confused and they say, how do I know whether it's just one inequality or two inequalities? Now, if you just look at all the examples we've done so far, when there's a finite amount of values, so you can see here it's just between 10 and minus 10, it's just one inequality. The last example, it was all values between 5 and 7, so it's just one inequality. The example before that, it was all the values continuing forever upwards, like that graph continues forever upwards. Same goes for this side, it continues forever upwards. So that's the reason why we need two separate inequalities to represent them. We can't stick them together. So that's how you know whether it's one inequality or two inequalities. Let's do one more example. So here, solve 2x squared minus 11x plus 9 is less than 0. Again, it's a quadratic inequality. We need to draw the graph. Find the two values where it crosses the x-axis. You can use the quadratic formula, but I'm just going to attempt to factorize here because of time. So it is minus 9 minus 1. So 2x squared minus 2x minus 9x, which is minus 11x, and then minus 9 times 1 is plus 9. Okay, if you're not comfortable using that method, use a quadratic formula like we've been going through this whole session. So therefore, our two values is either 2x minus 9 equals 0 or x minus 1 equals 0. This one's easy enough. It's just the opposite sign. So x equals 1 because I'm bringing minus 1 to the other side. Let's solve this for x. I need to get x by itself. 2x equals 9 because I've brought minus 9 over to the other side. And then x just equals 9 over 2. So I'm dividing by 2. So we've got our two values of x. We've got x is 9 over 2 and x equals 1. So like all the previous examples, let's sketch it on the graph and see where is it less than 0. So sketching the graph, I will just sketch it up here. So 9 over 2 is approximately 4.5. So, but no, it's not approximately, it is 4.5. So it's going to be around here, and let's just say 1 is going to be here. So our graph is going to look somewhat like this, where this is 1 and this is 9 over 2. So looking at the question, it's saying, where is this graph less than 0? So less than 0 is below the x-axis. Where is this graph below the x-axis? This is all this point here. So just to note as well, if you did have an n-shaped graph, so where this was a negative in front, your whole answer would change because you'd have an n-shaped graph, and that's another reason why we draw the graph as well. So do have a look at an example of that in your own time. It very rarely comes up, but it can come up. Okay, so we need all the values between 1 and 9/2. So all I can just say is x is between the two values 9/2 and 1. That's my answer for 4 marks. So that's all the examples I've got on quadratic inequalities. Let's move on and look at quadratic sequences now. So quadratic sequences, there's so many different ways to do this. So I'm going to show you one way. If you want to use this way, that's fine. If you want to use a method that you're used to and you still get the answer, you can stick with your method as well. I'll show you this method that I use. So it says the nth term of a sequence is 2n squared plus 4n minus 1. So I can see it's a quadratic sequence because it's got an n squared, it's got an n and a number. So it's in the form same like ax squared plus bx plus c. So we know it's a quadratic sequence. This one is straightforward. It's saying work out the 10th term of the sequence. So the 10th term, we're just substituting n equals 10 into the equation. So we've got 2 times 10 squared plus 4 times 10 minus 1. 2 times 10 squared. 10 squared is 100. 100 times 2 is 200. Plus 4 times 10, which is 40, minus 1, which we just get 240 minus 1, so 239. Easy enough. Moving on. Here are the first 5 terms of a quadratic sequence. So because they've told us it's a quadratic sequence, you know that that sequence is going to be of the form an squared plus bn plus c, where we need to find out what a, b, and c are. It says find an expression in terms of n for the nth term of this sequence. Okay, so this is the method that I use for this. So listing out the numbers 5, 11, 19, 29, and 41. I'm going to work out the first difference between each of these. So between 5 and 11, that's 6. 11 and 19, that's 8. 19 and 29, 10, and 29 and 41, that's 12. Okay, we then work out the second difference. Now your second difference always on a quadratic sequence is exactly the same. So this should all be the same. Between 6 and 8 is 2, 8 and 10 is 2, and 10 and 12 is 2. Okay, so we've done it right. Now there's 3 equations you need to remember. So in the method that I'm going to tell you, the first equation you need to remember is that 2a equals this number. The next equation is 3a plus b equals this number. And finally, a plus b plus c equals this number. So for a quadratic sequence, these 3 equations will always work. So that's just something you need to memorize. So 2a, 3a plus b, and a plus b plus c for the top one. And it goes up in that order as well. And all we're doing is we're just solving each of these equations to find a, b, and c. So we can plug a, b, c into here. So a, b, c. So that's the reason why we're doing it. Once we plug it in there, we've got the quadratic sequence. Starting off with 2a equals 2. So therefore, a just equals 2 divided by 2, which is 1. So we found a, so we've dealt with that one. Let's do the next one. We've got 3a plus b equals 6. We know what a is 1. 3 times 1 is just 3, plus b equals 6. So to get b by itself, I'm going to minus 3. 6 minus 3 is just 3. So b equals 3. And finally, let's do that top equation. We've got a plus b plus c equals 5. So let me just move this a little bit up so we've got some space. So we know what a and b is. A is 1, b is 3, plus c equals 5. 1 plus 3 is 4. 4 plus c equals 5. To get c by itself, minus 4 to the other side. 5 minus 4 is just 1. So we found our a, we found b, and we found c. We're just going to plug it straight into this equation, and we've got the quadratic sequence. We've done that one as well. So an squared, which is 1n squared, it doesn't really make sense to write 1n squared, so you just write n squared. I'm going to write n squared plus bn, b is 3, so 3n, then plus c, which is just 1. And that's our answer. So you can use this method, or you can stick with using your method. As long as you get the same answer, that's fine. But just to reiterate, these equations will always work for a quadratic sequence. Let's do another example, just to prove to you that it always does work. Here's the first 5 terms of a quadratic sequence again. So as soon as you see this word, quadratic sequence, you should be thinking an squared plus bn plus c, where we're finding a, b, and c. Show that the nth term is n squared plus n plus 4. So this is quite good because they've told you the answer in the question. So you're working towards an answer that they've already given you in the question. Let's work out the differences between each of these and see what we get. So between 6 and 10, 4, 10 and 6, 6, 16 and 24 is 10, and 24, 16 and 24, sorry, is 8. And then 24 and 34 is 10. The second difference that we get should just be exactly the same. Between 4 and 6 is 2, 6 and 8 is 2, and 8 and 10 is 2. Like last time, let's put our equations that we put last time. So 2a equals this number, 3a plus b equals this number, and a plus b plus c equals this number. And we're just solving each of them. So let's start off with this first one here. So 2a equals 2, so a just equals 2 divided by 2, which is 1. The next equation, 3a plus b equals 4. We know what a is 1, so 3 times 1 is 3. 3 plus b equals 4. To find b, I'm just going to do 4 minus 3, which is 1. Let's do the top equation. We've got a plus b plus c equals 6. A is 1, b is 1 from what we found before, and c we're finding equals 6. 1 plus 1 is 2. 2 plus c is 6. So c just equals 6 minus 2, which is 4. So we found our a, b, and c. We are just plugging it straight into a, b, and c here. So we get 1n squared plus 1n, bn, plus c, which is 4. I don't really need to write the ones in front, so I can just say n squared plus n plus 4. And that matches exactly what was given in the question. And that's for 4 marks. So that's quadratic sequences. Moving on. Oh, okay. So there's one little question here. I don't really have space to do it, but I'm just going to talk about it. So it says here, hence determine whether 136 is a term in the sequence. What you do for this one is, with n always has to be an integer. So for example, just to prove to you, when n equals 1, 1 squared is 1, 1 plus 1 is 2, 2 plus 4 is 6. When n equals 2, 2 squared is 4, 4 plus 2 is 6, and 6 plus 4 is 10. And then when n is 3, it'll give you 16. When n is 4, it's 24, and so on. So n has to be an integer, where integer just means whole number. So it cannot be a fraction, a decimal, so on. It has to be an integer. So if I want to know whether 136 is a term in the sequence or whether I continue the sequence and I get 136, what I have to do is I have to get the equation we've just found, n squared plus n plus 4, and I'm going to make it equal to 136, and I'm going to solve it. So remember, when you're solving quadratic equations, we always have to make the quadratic equal to 0. So I'm going to minus 136 over to the left-hand side. I get n squared plus n. 4 minus 136 is minus 132. That equals 0. You can use a quadratic formula, or you can factorize it to get the answer. But when you do factorize it and use a quadratic formula, which you can try in your own time, you should get n equals minus 12. And you should get n equals 11. Now, we can't have a negative number for a quadratic sequence. Like, n cannot be negative either. It has to be just a positive integer. So I should have really wrote positive integer there. So we ignore the minus 12. We accept the 11. And because 11 is an integer, then you say 136 is a term. Now, if we ended up with like 2 decimal answers, then 136 is not a term. So because we've got an integer, which is 11, that's the reason why it is a term. Okay, moving over to functions. Okay, so we've got a few functions questions. So we'll do a few different examples. We'll start off with just substituting a number into a function. We'll do composite functions, solving functions, and inverse functions as well. So starting off simple, g of x equals 2x squared minus 10. Find g of 2, sorry. So to find g of 2, all we're doing is we're just substituting 2 in for x. So we get 2 times 2 squared, so I plug 2 into there, minus 10. 2 squared is 4. 4 times 2 is 8. 8 minus 10 is just minus 2. Let's do the next one. We've got g of minus 2. So g of minus 2, I get minus 2 squared. So I'll put it here, minus 2 squared times 2, minus 10. Now, minus 2 squared is just 4, and 4 times 2 is 8. 8 minus 10, again, that gives us minus 2. We've then got solve g of x equals 8. Now, g of x just equals this here, and we're just making g of x equal to 8. So all I'm doing is I'm changing g of x for what g of x is, which is this here. So 2x squared minus 10 equals 8. So we're just solving this. Let's plus 10 to the right-hand side. So 2x squared equals 8 add 10, which is 18. Let's divide by 2 to get x by itself. 18 divided by 2 is 9. And x just equals the square root of 9, which is plus or minus 3. So that's our answer. Make sure you write both positive and negative answer. Remember, 3 squared is 9, but minus 3 squared is also 9 as well. Moving on to question 2, we've got some inverse functions here we need to find. So again, there's a few different methods to do this. I'll show you my method. And if you've got a different method that works, you can stick with that. So we've got two functions given to us, f of x and g of x. It says work out an expression for the inverse of g. So g to the minus 1 of x just means the inverse of g of x. Now, the way you work that out, here's g of x here. I'm going to change that g of x to a y. So y equals x plus 3. So that's the first step. I've just replaced that g of x with a y. It's just easier to work with, that's why. The next step is I'm going to make x the subject of the formula. So I'm going to minus 3 to the other side. So I've minus 3 to the other side, and I've made x a subject. And that's our final answer. We just need to write it correctly. So g to the minus 1 of x equals what we've just found here. But remember to change that y back to an x, because this function is in terms of x. So it's just x minus 3. Okay, part B says work out the expression for the inverse of f of x this time. So f to the minus 1 of x. We're looking at this one here. Change that f of x to a y. So y equals x squared minus 17. And I'm getting x as the subject. So I'm going to plus 17 to the left-hand side. So y plus 17 equals x squared. And to get rid of that squared, the opposite of squaring is square root. So I'm going to square root y plus 17. That equals x. So I've got x by itself. What's my final answer? My final answer is not g, sorry. It's f to the minus 1 of x equals what we've just found here, but make sure to change that y back to an x. So we get square root of x plus 17. And that's our answer for that one. Okay, we've got some composite functions now. Now, composite functions just means function in a function. We're given two functions again. So we're given f of x and we're given g of x. And it says find g f of 3. So we call this a composite function. So it's two functions together. Now, with composite functions, you always do the inside part first and then you do the outside part. That's just a generic rule. So inner first, then outer. Okay, so took that out. So we're going to do f of 3 first. So f of 3, we're just plugging in 3 for x in f of x. So we get 2 times 3 minus 4. 2 times 3 is 6. 6 minus 4 is just 2. So we found f of 3. Now our answer to that, f of 3, we're just plugging into g. So g of 2, which is the same as g of f of 3, but we found f of 3 now. G of 2, we're just sticking 2 into g of x. So we get 3 times 2 plus 5. 3 times 2 is 6. 6 plus 5 is just 11. And that's our answer. Okay, moving on to part B, we've got an inverse question again. So it says find the inverse of f of x, so f to the minus 1 of x. Just like last time, change the f of x to a y. Write this down, 2x minus 4, so y equals 2x minus 4. I'm making x the subject, so I'm going to plus 4 over to the left-hand side, so I get y plus 4 equals 2x. And then to get rid of that 2, I'm dividing by 2. So I get y plus 4 divided by 2 equals x. So my final answer is f to the minus 1 of x equals what we've just found here, but again, remember to change that y back to an x. So we get x plus 4 over 2. So that's part B. Okay. And for part C, we've got f of x equals g of x. Now, if we look up here, all we're doing is, for f of x equals g of x, when we're solving, remember solve just means find x. We're finding the unknown letter. And what we're going to do is we're going to make f of x equal g of x. So f of x equals g of x. I'm just going to plug in them into the equation here. So we've got 2x minus 4 equals g of x, which is 3x plus 5. And that's what I'm solving. So I'm going to bring all the x's to one side and bring all the numbers to one side. I'll probably try and keep x positive so it's easier to deal with. So I'll minus 2x over to the right-hand side. So I get minus 4 equals 3x minus 2x, which is x plus 5. And to get x by itself, which is what we're solving, I need to get rid of that 5. So I'm going to minus 5. So x equals minus 4 minus 5, which is minus 9. And that's our answer. So x equals minus 9. Okay, let's do question 4. Given that f of x is 3x plus 1 and g of x equals x squared, find f of g of x. So remember with composite functions, we do the inner first and then the outer. Well, what is g of x? G of x is x squared. So we're finding f of x squared because we can't really solve g of x. It's just x squared. So wherever there's an x in f, I'm just replacing that with an x squared. So we've got 3x squared plus 1. And that's my answer, just 3x squared plus 1. Okay, moving on, we finally got algebraic fractions. So that should be a squared. It's not that clear here, but that is a squared there. So it says simplify fully x squared plus 5x over x squared plus 7x plus 10. Now, whenever we've got algebraic fractions, we're just factorizing and we're going to be just cancelling out on top and bottom. That's the whole point. The only way we can simplify it, so we need to factorize it and get into brackets. To factorize x squared plus 5x, I can pull out an x, then x times x is x squared, x times 5 is 5x. And then the bottom one, I need two numbers at times to give me 10, and two numbers that add to give me 7. So 5 times 2 is 10, and 5 add 2 is 7. So I can see the plus 5 term, x plus 5, that cancels out. So we're left with just x equals, not x equals, x over x plus 2. That's my final answer for this one. Let's do part 2. Again, simplify fully this algebraic fraction. Let's factorize the top and bottom. The top, to factorize that, 3x squared plus 9x. So I can pull out a 3. I can pull out an x, just one maximum. Start my bracket. 3x times something gives me 3x squared is just x. 3x times x is 3x squared. Plus 3 times 3x times something gives me 9x. Well, 3 times 3 is 9. and we've already got the x, so we're done with that. On the bottom, that's difference of two squares because we've got x squared and we've got 9, which is a square number, and we've got a minus in between it, so that's just difference of two squares. So for the bottom, I get x plus 3, x minus 3. So therefore, we can cancel out the plus 3 on the top and the bottom. So we're left with just 3x over x minus 3. Okay, we've now got this one, which probably a lot of people skip because they'd get a bit scared of. But it's just combining your fraction rules with it as well. When you've got two fractions and you've got a divide sign there, you're just doing your keep, change, flip method. So you're keeping the first one, you're changing the second divide to a times, and then you're flipping the second fraction. So that's all we're doing here. So I'm going to do that, but I'm going to attempt to factorize at the same time as well. So 2x minus 2, how can I factorize that? Well, I can only pull a 2 out, x minus 1. So 2 times x is 2x, and 2 times minus 1 is minus 2. X plus 5, I can't factorize that anymore, so I'll just leave it as x plus 5. I then change the divide to a times, and we're going to flip the second one. So I'm going to attempt to factorize this bottom one, and it goes on top, remember. So I get 2x and x. Let me write that a bit better, get some space. So for the first one, I get 2x. The second bracket, I get x. Two numbers at times give 15, 3 and 5. And then 2x squared plus 10x plus 3x, which is 13x, and plus 15. Okay, if you're not comfortable just doing it like that, use the quadratic formula method that we used before. And that's over factorizing the top. That's x in both of them. And then we've got two numbers at times to give us 3 and to do minus 4, so minus 1, minus 3. Now, since we're timesing these fractions, we can combine them together. So I can just say 2 times x minus 1 times 2x plus 3 times x plus 5 all over, just put a bracket around this so you don't mess that up, x plus 5 times x minus 1 times x minus 3. Now, a common mistake people tend to make here is they start expanding again, but we don't want to expand because you're just going to end up with the same thing again. We want to cancel down with simplifying. So what can we simplify? There's an x minus 1 on top and bottom. There's an x plus 5 on top and bottom. So we're left with just 2 times 2x plus 3 on the top, and divided by, we've got x minus 3 on the bottom. So therefore, we wouldn't leave our answer, you could leave it like that, but I would probably expand that. I would say 2 times 2x is 4x, and 2 times 3 is 6, all over x minus 3. I'm pretty sure they would accept that in the mark scheme as well, because there's two answers to that. So 4x plus 6, x minus 3. Okay, so that's question 3. So that was simplifying algebraic fractions. Now let's do a solving an algebraic fraction. So let's do this one here. So solving algebraic fractions. So we've got 2 over 5 minus x plus 3 over x plus 7 equals 1. So what does solve mean? Solve means find x. So to find x, and we've got two fractions here and we're adding. Remember, when we're adding fractions, the denominator has to be the same. So for this first one here, so let me just write it out again. So 2 over 5 minus x. On the denominator, the only thing I can have that can be exactly the same is both of them brackets. So on the denominator, I'm going to try and get 5 minus x and x plus 7. That's what I want on the denominator for both of them. So for this first one then, in that case, I'm going to times the top and bottom by x plus 7 on the top and the bottom. Now remember, if you're timesing the top and bottom by the same thing, it's like you're timesing by 1. It's a bit like when we're rationalizing surds as well. If you're timesing the top and bottom by the same thing, it's like you're timesing by 1. You're not really changing the fraction. You're just manipulating it. So that first fraction, I'm timesing the top and bottom by x plus 7 because I want this as the denominator. Let's deal with the next one now. So we've got plus 3 over x plus 7. Now on the bottom, I need 5 minus x. So I'm going to times the top and bottom by 5 minus x. And that just equals 1. Okay. So don't start expanding the bottom, just leave it there for now. We can now combine these fractions together because the denominator is exactly the same. So on the top, I would have 2x plus 7, which I'm going to expand. So 2x plus 2 times 7, which is 14. And I get plus 5 times 5, which is 15. And 3 times 5, which is 15, yeah. And 3 times minus x, which is minus 3x. That's all over this bottom denominator here. Let's expand it. We'll just expand it just because we don't have a lot of room to work with. Bring this a bit here as well. Okay, so 5 times x is 5x. 5 times 7 is 35. Minus x times x is minus x squared. And minus x times 7 is minus 7x. And that just equals 1. Let's simplify everything now. So we've got 2x minus 3x on the top, which is just minus x. 14 add 15, which is just 29. And that's over 5x minus 7x, which is minus 2x. And we've got a minus x squared then, a plus 35. So let me just put that there, minus x squared plus 35. We'll deal with the order after, and that equals 1. Now, we can't solve like with the denominator, so let's bring that denominator up to the top here. I'm just going to put a line here just so I can work with it a lot easier. On the top here, I've got minus x plus 29. And then I'm going to do 1 times, I'm going to bring all this up here. So that 1 times, I'll just leave it the same. And I'm just going to put it in the form like x squared first, then an x, and then a number. So let's write that minus x squared. Then we'll write minus 2x. And then we've got plus 35. So I've just brought times that up to the top. Now, I've noticed that this is a quadratic because I've got an x squared, an x, and a number. So remember with quadratics, we must always equal them to 0. And it's easier to work with a quadratic, like solving it, if your x squared term is positive. So I'm just going to bring everything that's over here to the left-hand side so I can get this x squared positive, just to make it easier. You could bring everything to the right-hand side, but you're just making it harder for yourself. I'm going to bring everything over to the left-hand side. So positive minus x squared becomes plus x squared. So that comes here. And then we've got minus 2x. So I'm going to plus 2x. Minus x plus 2x is just plus x. And then we've got 29 minus 35, which gives us minus 6. And that equals 0. So now I'm just solving this. So let's do the 2 bracket method. You could use quadratic formula to be fair, but this one's pretty straightforward. 2 numbers at times to give us minus 6 and add to give us 1. That is minus 2 plus 3. Minus 2 times 3 is minus 6. Then minus 2x plus 3x is plus x. Yep, that's fine. And finally, to solve that, so x could equal 2, so the opposite sign, or x could equal minus 3. That's my 2 answers for solving an algebraic fraction. Okay, let's now move over to another topic, and I believe this is the last topic for this one. Yep, so this is quadratic simultaneous equations. So it says solve the simultaneous equations. We've got x squared plus y squared equals 13, which is you should recognize as equation of a circle. And we've got x equals y minus 5. So when we're solving simultaneous equations, the reason why we get 2 equations is because we're finding x and y. So we're finding x and y. So that's the reason why they give us 2 equations. If we were finding 3 things like x, y, z, they would give us 3 equations to be able to find that. So that's the reason why we've got 2 equations. Now, to be able to solve an equation, we have to have just 1 equation just with 1 letter. That's what we're aiming for. So what we could do is we could substitute this, which is x equals y minus 5, into x here, and then our top equation will just be in terms of y. So let's do that. We've got x squared. I would recommend telling the examiner as well what you're doing, but understand yourself why you're doing each step so you can apply it to more difficult scenarios. So y minus 5, I'm going to stick into x. So it's y minus 5 all squared plus y squared equals 13. So that's perfect. We've got an equation just all in terms of y, and we can solve that. This y minus 5 squared, remember it's y minus 5 times y minus 5. A common mistake students make is they just say it's y squared minus 5 squared, so which is plus 25. That's completely wrong. It's y minus 5 times another bracket y minus 5 plus y squared equals 13. Let's expand. You can use a grid method or your normal FOIL method. Y times y is y squared, y times minus 5y, minus 5y again, and then minus 5 times minus 5 is plus 25. We've got that plus y squared here, and that equals 13. Let's collect like terms. Y squared add y squared is 2y squared, minus 5y minus 10y plus 25 equals 13. So we've got a quadratic here. What do we always make quadratics equal to solve them? We always make them equal to 0. So I'm going to bring 13 over to the left-hand side. So we get 2y squared minus 10y, and then 25 minus 13, we get 10. That equals 0. 25 minus 13, we get 12, sorry. Don't want to be making basic mistakes. That's just proof to always just check every step of your working out as well, and not just to continue, like it just seemed a bit wrong. So now 2y squared minus 10 and 12, they're all multiples of 2. So to make this even easier, I can divide the whole equation by 2. So I get y squared minus 5y plus 6 equals 0. Now remember, you can only divide something by 2 and simplify it if it's an equation. So it's equal to something. If you've got an expression means something that's not equal to something. You cannot just divide it by 2. So that's the rule. Like, a lot of people get confused. How do I know when I can divide and times up an equation? If it is an equation, which means it's equal to something. If it's just an expression, you can't change that by a multiple. Okay, so to solve this, let's just try and factorize it. Minus 6 minus 1, no, because that's not minus 5. Minus 3 minus 2. So minus 3 times minus 2 is 6, and minus 3 add minus 2 is minus 5. So therefore, y either equals 3, so the opposite sign, y equals 3, or y equals 2. So we've got our two answers to y. Now we just need to find x. So all we're going to do is, I'll just highlight these because they're my two answers. All I need to do to find x is I'm going to substitute the y back into one of these equations and I'll get x. You can use any equation, you'll get the same answer, but why would you use a hard equation? You would use an easier equation to be able to find that. So I've got x equals, for this case scenario, I've got x equals, I'll just do it down here actually. Let's put that there. X equals y minus 5, which is 3 minus 5 in this case. So x just equals minus 2. That's our first answer of x. And the next one, x equals y minus 5. Y is 2. 2 minus 5. So x equals minus 3. And there's my four answers. Now I just want to give you some extra information about this. We've got equation of a circle. That top one here is x squared plus y squared equals 13. Let's just say it looks like this. And we've got x equals y minus 5, which is just a linear equation. I'm just going to give a guess. Let's just say it looks like this. Sorry, let's just say it crosses a circle just like this. So you can see that this linear line crosses a circle at two spaces, where we've got an x and a y coordinate here, and we've got an x and a y coordinate here. That's the reason why we get four answers. We've got two x's and we've got two y's. So that's the reason why we've got two x's and two y's when we solve this. So that's how you look at a simultaneous equation graphically. It's where your two equations are intersecting each other, which you need to be aware of as well. Okay, let's do this next and final question. So we've got solved these two simultaneous equations. How is this different from the last example? Well, if you look at this last equation here, so we've got equation of a circle again. And this equation here, again, it is a linear, it's y equals mx plus c, just all mixed up. But in the last example, they already made x a subject. So you have to do that additional step yourself. So you could either make y the subject, you could make x the subject, it doesn't really matter, you'll get the same answer. It's your choice. So we've got one extra step. We need to either make y or x the subject, and then we're going to plug into the first one again. And it says give your answer to 3 significant figures. That's a big clue. We're going to be using the quadratic formula for this one. So let's rearrange this to make y the subject. Well, y is negative. I want to make it positive. I'll bring it to the other side. So I get 2x equals 3 plus y. And I want y by itself. So I'm going to get rid of that 3. So I get y equals 2x minus 3. So there's my rearranged equation. I've now got y equals 2x minus 3, which you should also know what it looks like. It's like a positive gradient graph crossing at minus 3, and it's crossing this circle. Okay, so now what I'm going to do is I'm going to plug this, that is not the highlighter, I'm going to plug this into y over here. That's what we're going to try and do. Now you can make x the subject and then plug it in for x. You can do that as well. You'll get the same answer. I just saw that y was by itself, so it seemed easier to work with. So let's plug 2x minus 3 into the first equation. So we get x squared plus 2x minus 3 all squared equals 27. That gives us x squared plus 2x minus 3 times 2x minus 3 equals 27. Let's expand. X squared plus 2x times 2x is 4x squared. 2x times minus 3 minus 6x. Minus 3 times 2x is minus 6x again. Minus 3 times minus 3 is 9 equals 27. If you've got time in the exam, I'd recommend checking each step as you go, because you don't want to make a mistake here and it follows through the whole way and then it's hard to change. So I would recommend just double checking that. We get x squared plus 4x squared minus 6x is minus 12x plus 9 equals 27. I could have simplified that first part, actually. I could have said x squared plus 4x squared is 5x squared. Just totally missed that off. Okay, so we've got a quadratic because we've got x squared, x, and a number. What do we always make quadratics equal to? You'll see that recurring theme throughout. We always make quadratics equal to 0 to be able to solve it. So let's bring 27 over to the left-hand side. We get, keep it blue, 5x squared minus 12x. And then 9 minus 27, we get minus 18. And that equals 0. Okay, I can't really simplify this equation because a number doesn't go into 5, 12, and 18. So I'm just going to have to use a quadratic formula here to solve this. A big clue that we use in the quadratic formula is this: you give your answer to 3 significant figures, so it's not going to factorize nicely. So what's the quadratic formula? X equals minus b plus or minus b squared minus 4ac all divided by 2a. You'll get given that in the exam. A is 5, b is minus 12, c is minus 18. So just your coefficients in front. Let's plug all that into the formula. We get x equals minus b. We've got b is minus 12, so minus b is minus 12, which is just plus 12, so it's the opposite sign. Plus or minus b squared minus 12 squared is 144. Then we've got minus 4 times a, so minus 4 times 5, times minus 18, so we get plus 360. All divided by 2 times a, which is 2 times 5, which is just 10. Simplifying that further, I get 12 plus or minus the square root of 144, add 360, I get 504, all over 10. Working that out, I get my 2x values as, to 3 significant figures as well, 3.44 and minus 1.04. Now, one thing I just want to note here, which I should have really done here, but just in essence of time, you should have your actual long answers for x ready. So what I mean by that is, I'll just actually work out here. So if I've got 12 plus the square root of 504 over 10, I get this long number here. Probably can't see that because of the camera's quite blurry. But anyways, x equals 3.44499. I'll just keep it to that. And for the second one, I get x equals minus 1.044994, so on. Now, the reason why I'm writing that down is because when I find my y answers, I'm going to substitute these x's back into one of these equations, just like last time. But I'll choose this equation here because it's already got y equals. I know a lot of teachers say always use these original equations because they're not confident in your answer. But if you're confident in your answer, just use your rearranged version if it's got y equals, just to make it easier. So when we're working out y, we're going to do 2 times x, but not 2 times this x because this is rounded. And we don't want to get any rounding errors, so make sure you plug in the long version. So 2 times 3.444, so on, minus 3, and then we get y equals 3.89 to 3 significant figures, which is what we're finding it to. If you end up plugging this rounded version in, you'll end up getting rounding errors, and you might end up getting like 3.88, and that's wrong. You won't get the mark for that. So same with this second example, y equals 2 times x, and x, we're going to take this one, minus 1.04499. Put it as long as you can in the calculator as possible. And we're minusing 3, and to 3 significant figures, you get minus 5.09. And that's your fourth and final answer. So yeah, just to reiterate, please don't use your rounded answers when you're substituting back in. Use your unrounded answers. And then, yeah, that's your 4 answers. X equals 3.44 minus 1.04, which you'll write down here. And same with your Y, you get 2 answers again. And graphically, if you were to think about that, it's a circle, a straight line crossing through it, and it crosses at 2 points on there. So that's the reason why we've got 4 answers altogether, 2 X's and 2 Y's. And that's the end of that. So I hope that was helpful. That was covering as much of advanced algebra as possible for GCSE maths. If you've got any more session requests, do get in touch, and check out all the other sessions as well that we've got recorded. Thank you for joining, and see you on the next one.